Climate change is frequently framed as a linear, century-long rise in average temperatures. The reality is the active assembly of a planetary greenhouse. By altering the atmosphere, we strip away the thermostatic shield that historically regulated Earth's heat. This creates a thermal cage, a chemical boundary that forces solar energy to accumulate within our weather systems. If the accumulation continues, the system crosses a mathematical threshold where the warming becomes self-sustaining and independent of human activity. At this point, the climate exits our control. Even if all industrial emissions ceased immediately, the geographic feedback loops would continue to drive temperatures upward. To find the trigger for this autonomous heating, we have to look miles above the surface, at the microscopic interactions in the upper atmosphere. Molecules of carbon dioxide and methane are multiplying within this boundary, thickening the atmospheric layer. This diagram illustrates the physics of these molecules. High-energy solar radiation easily bypasses this molecular barrier. Once hitting the surface, it converts into low-energy heat. When attempting to escape back into space, the molecules block its path, forcing the energy to bounce back down. This chemical imbalance provides the spark that activates Earth's dormant geographic feedback loops. The most immediate vulnerability is the polar cryosphere, ice shelves so massive they regulate the temperature of entire hemispheres. These ice sheets utilize the albedo effect, reflecting incoming solar heat away from the surface, like a massive planetary mirror. As the atmosphere warms, the white surface begins to melt, uncovering the dark ocean water trapped beneath the ice. Dark water absorbs more solar energy than white ice. This extra heat accelerates the melting of the surrounding shelves, exposing more dark water and creating an unstoppable cycle of absorption. This trapped thermal energy raises ocean temperatures, forcing the water to physically expand while the chemistry shifts toward acidity. As the water becomes warmer and more acidic, it begins to dissolve the calcium carbonate shells of base-level organisms, destabilizing the marine food web from the bottom up. The atmosphere absorbs the excess heat from the sea, supercharging weather systems into massive supercell storms with unprecedented energy levels. On land, the increased evaporation fractures green landscapes, turning fertile geography into arid, cracked earth. Earth's natural systems have flipped. They no longer buffer the heat, they now actively amplify the warming. These cascading geographic failures persist beyond the initial weather event. Our planet Earth is shifting toward a new, higher-temperature permanent equilibrium, a state defined by a total geographic rewrite. The loss of global ice shelves represents a physical finality that cannot be reversed on a human timescale. Because the terrain itself has fundamentally altered, attempting to preserve the climate of the past is no longer a mathematically viable objective. Humanity faces a choice. We must execute a radical adaptation to this new, hostile environment, or simply become part of the geological record.